right, I think we're streaming. Let's see. Did it start? Here we go. Right, let's pop this out. Bring this over here. Yeah, here we go. And I'm gonna post a stream on my socials, and then we'll get started. All right, so gonna add a little link. And I'm also gonna post it in here, in a couple of these places. So let's paste it in right here, and Nice. All right. So, in between the last stream and this one, actually, I should also make. I'm actually gonna quit this. Yeah. In between the last stream and this one, I got the Triton Puzzles Lite repo working and posted my progress onto GitHub. So if you want to see the solutions, go to my GitHub, go to the Triton repo, look in Triton Puzzles Lite. I'll post a link later. But this also lets me know that it's working on actual GPU because we have, if I connect to my friend's server right here, friend's name is Max. He lent me his 1660 Super, and we can run our test on there. It's old architecture, right? It's a Turing architecture, so we might encounter later. We might end up encountering errors casting between FP32 and FP16. But for now, especially for some of these like more basic challenges, we should be able to run it just fine, right? We can see right here, NVIDIA SMI. We got our GeForce GTX 1660 Super, so on. See our stats. Cool, right? So I'm gonna make sure I go into JIT and Triton, Triton Puzzles Lite, just like this. And I also want to make sure that I activate my virtual environment, right? So I should probably just open it in here. Just like this. Yep. And let's make sure that we activate our virtual environment. Bam. One more thing. I tried to think a bit about what I did last time and what I could improve on, right? And one thing was just like, I want to make sure I eat. I think not eating beforehand actually made like a significant impact, but something that's more relevant to all of you is just like, so, you know, in my studies so far, I think I've been pretty intentional about like absorbing the algorithmic principles and also just like generally what I should be doing when I'm thinking about the programs, like thinking about pointers and thinking about indexing in the C style, thinking about masking, thinking about parsing things in blocks and such and so on. But I haven't been as intentional about really like internalizing what each data type I'm interacting with is. And I think for actually doing the Triton programming, that's something I should be a bit more intentional about versus just like sort of trying to wave my hands. So this time when I'm passing in arguments and such, I'm gonna be more intentional about like saying what types they are versus just what they represent, right? So for example, I think with the last challenge I did, it would have been much easier for me if I had been thinking about this as an array of booleans versus just sort of trusting that NumPy or Triton was gonna broadcast things how I'd want it to, you know? I know it was an array of booleans, but thinking about that more explicitly allows me to do things like this, right? Like doing slicing, doing broadcast and multiplications, and not having to sort of overcomplicate my code, right? But so, let's continue. I think next challenge was puzzle 5, fused outer multiplication. Prompt is multiply a row vector to a column vector and take a ReLU. Use two program block axes. Block size B0 is always less than the vector x, length n0, so on. So this is pretty similar to what we did before, except now we're doing a product. Okay. You know, something to think about is like if we're doing ReLU, we could just look at signs and stuff, but alright. We have PID 0, PID 1. Let's draw what we're going to do first. We can kind of reuse this, right? When I'm looking at my blocks, I want to be multiplying these and only taking the ones that are greater than 0, writing them into here. The logic's going to be pretty similar. So first thing I'm going to do is I'm going to load in my X and Y blocks. One thing I want to do is I don't think I've ever actually printed X pointer and Y pointer. So that was something I wanted to do at the start of this. I wanted to guess what the types are, what it would look like when I print it, before I print it, and see if I have a good understanding, right? So, for example, right here, if I print X pointer, what I think is happening, right? When I make tl.arange, it's creating something that looks like a NumPy array, like when I'm in the right interpret mode. And those are my index offsets, right? So like if I have an array and I want to look at indices 0, 1, 2, 3, 4, 5, 6, 7, I use this tl.arange. And so if it works sort of like how it would in C, I would expect X pointer to actually just be like an integer, sort of like a literal address, maybe look like a hex value or something like that, right? And then when I'm adding it together, so like X pointer plus range, it's broadcasting that sum over the range, right? So that way, instead of the range just being 1, 2, 3, 4, 5, 6, 7, it's address plus 1, address plus 2, and so on, right? But let's see if that's actually like what's going on, or if it's represented differently. Oh, I have to like restart the whole notebook. You know, one thing I'm thinking about with this multiplication is like, it might be the case that something goes out of bounds. When we're thinking about like our floating point data types, but I'm gonna just assume stuff is in bounds for now, and we can tackle things as they come. All right, let's see if what I was describing is actually what's happening. What is that? No, it was working. What happened? Ooh. I think we might need to do that. Yeah. No matching distribution found for Triton 3.1.0. Let's try that. But man, why didn't we need to do that before? Let's look at my copy and see if there's something that changed or not. I think not. See if running this does what we expect. Funny thing is, this time, if it breaks, I actually have the other one working, and so we can continue on there. But I prefer on here because the visualizations were nice. By the way that I resolved this one was that the reason it was erroring out when I was running the script before, when I was running this, was because the NumPy version that was getting installed was too recent, basically, and it caused inconsistencies, and you could catch that if you looked at the demo, right? So there's like a command in here that says something about demo somewhere. Like this one, the -I think. Yeah, it shows these demos. Before, this was coming out as all zeros, so I think some masking wasn't working properly or something like that. It was causing the test to fail even if I had the correct solution. But now it's not failing, and so I can test, and so if I omit this try and interpret, it does it directly on the GPU. LOVM compiles onto PTX, and then to our target Turing architecture, and we can see the puzzles up to puzzle 5 were solved. Let's check out over here. Yeah, I don't know what's up with this. It's strange. Are we even using Record Builder anywhere? Did I just skip this last time? Let's see if it... Did I just skip this last time? Let's see if it just works anyway. But... yeah, no. I don't really know what I did differently last time. I might look at the beginning of the stream, but like if I can't figure it out, like it might be worth just moving on to the working scripts. Man, why does something keep messing up each time? It's all right. This is what happens when you do lives. Things go wrong. I really wonder what's up though. Like, I didn't change anything. Let's just maybe I need to restart the whole need to restart the whole kernel, like everything, right? Then let's try this. See if things go a little differently. Maybe there was something cached that was, maybe one of these packages was cached and it was messing stuff up. Yeah, see, the requirement already satisfied. Is that because Colab comes with that? One more thing I might do before I abandon it is look at the GPU mode Discord. Yeah, because I already know this is gonna mess up now, right? Like, I wonder why I can't install this version of Triton. So I'm gonna check one more thing, which was that in the GPU mode Discord, I'm pretty sure they had a tip for how to fix this, if I remember correctly. I forgot about that until just now. Let's not capture it. Let's see what's going on. The only thing I can think of is that I've been using Colab for a research project, and maybe when you, maybe they're just simply things that get like cached across notebooks. don't know what's up with that. Yeah, one more thing I should check is like yeah, it's not there. But one more thing I should check is what is the Triton version here, right? Like if I say pip list. It is 3.1.0. Why can't I install 3.1.0 on Colab anymore? Like this isn't gonna work now, right? Yeah. Well, I do want to get working, so I'm gonna do it over here. And if I run into trouble, maybe I'll come back. But let's just give it a shot, right? I got block ID X, block ID Y. So how do I turn off Copilot? Or that's not so Copilot, that's Super Maven. Let's toggle it off. And so first thing I'm gonna do is I'm gonna load the piece of X, right? So let's say X, let's call it X offsets equals, well actually not first thing I'm gonna do. First thing I'm gonna do is what I just said before. I wanna see what do my pointers and stuff look like. So if I say print X pointer, what does this do? Let's try it. It's a list with a single number in it. So it's a little bit different than I expected. I did expect it to just be a number, the address, but I do think this is the address. But I didn't expect it to be a list with an address. That's a bit super. Oh, that might just be a formatting thing though, right? It might just be like a repper thing. Yeah, because this is a Triton tensor. How about TL.A range? What's the type? I'm guessing it's also just a tensor, but yeah. And when I print this, I expect it to be like something that looks like a list with 0, 1, 2, and 3 in it. Yeah. Okay. So I'm gonna put my X offsets as TL.A range 0 to B0. And I'm gonna put my Y offsets as 0 to B1. Then I can load in my X block as TL.load. Let's see. TL.load, we want our X pointer plus our X offsets. And we want to make sure that our X offsets are less than N0 so that we don't read memory that we don't have access to. We'll do the same thing for Y. Like that. And one thing I was going to do also was print this. This should look like an array of booleans, if I'm correct. Right, we have our array of indices. We compare it with the int, and therefore we get an array of booleans because it gets broadcasted across the array. Yep. Kind of interesting that it's always true here. That means I'm probably doing something wrong, right? Or, yes, I am doing something wrong. These x offsets, they need to be adjusted by which block we're on, right? So if I'm on block ID X, block ID Y, I'm going to call this PID 0 and PID 1. And basically, I need to make sure that I'm jumping ahead however many PIDs I am, because this represents what block I'm on, right? So B0, and then same thing right here. 1. This time, we should see false, at least on the last one. True, 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 and then we start seeing false, right? Nice. So we have our X block and our Y block. Now we want to compute our outer product, which is going to be this torch.relu right here. Right? We create a row vector and we create a column vector, multiply them. I'm going to put block right here. I'm going to put block right here. And then now we want to write this to, wonder if we shouldn't be doing torch.relu here. Is there like a tl.relu or something? Well, we'll see, right? I kind of suspect that this might break a little bit, but we'll see. Actually, let's just run it and see what happens. Like this. Yeah. So I'm not actually sure how I would do the relu, right? I might suspect that there's like a, first of all, do I have my language server on? Restart language server. Because I don't really know why it's not recommending stuff, right? Do I need to select interpreter or something? I mean, this looks right. I might ask ChatGPT on this one or something. I'd use maximum. I see. So instead of torch.relu, I would say tl.maximum of outer product and 0, right? Basically, that's going to take any negative elements and replace them with 0, and any other elements remain the same. Let's see if that worked properly. Looks like it. All right, so now let's write this into our z pointer, right? Excuse me. So we have our, we're going to say tl.store. It's going to be z pointer plus z offsets, and we're going to put a mask, which is our z mask. And the thing that we're writing is going to be our outer product, right? But in this case, what should this look like? Our z offsets should probably just look like our x offsets and our y offsets. But how should they be arranged? Well, so I have a 2D array, right? So what I want to do is I want to do my sort of like I times n plus j sort of looking thing, right? So here I'm probably going to say I'm going to put a column vector here. So this is going to be none like this, and then I'm going to put n0. This is sort of like my offset for when I'm considering 2D arrays, and then I'm going to put a row vector here, right? So I want to say none, like this. And our mask is going to be, I need my x offsets to be less than n0, my y offsets to be less than n1. I need this to be broadcasted over a 2D array again, right? So I need, let's see. I think I do something very similar to right here, right? I would say x offsets less than n0 and y offsets less than n1, and this should be an and let's just try it, right? I mean, I didn't think too much about the shapes there, but like it might just work, right? Invalid access mask. Looks like I didn't do it right. So, what should I be thinking about here? Well, first of all, let's just mess with like some kind of like baby arrays or something, right? I want to understand this a little better. So let's say x equals tl.a range, I don't know, 1 to 4, y equals tl.a range, 6 to 9, and then let's just look at like what is print x of none less than, I don't know, less than 3, and y of none less than 8 look like? What does this look like? Let's try printing it. A range must be a power of 2. Let's just make this an 8. A range must be a power of 2. Does that mean that the top needs to be power 2, or the difference between like what if I said 4 and 8, and then 8 and 16? I made this a 15. I made this a 7. Would that work, or does it need to be from 0? Yeah, that works. So over here, right, I have something that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is way more. Oh no, that's the wrong thing. I want this right here. Yeah. It's a bit big though. Maybe let's try 12 here and 11. Maybe that'll work. Hopefully it'll work. Yeah. Damn, it's still kind of. It's a lot more elements than it should be, right? Like, this should basically just be like a 4x4 array, right? So maybe let's try swapping these and see if it becomes a 4x4. Ooh. Anyone in the chat? No. Alright. Let's try even smaller. Let's try 6 and 10. And then let's make this like a, I don't know, a 5 and 9. Wait, where am I even looking? Here we go. Now we've got this. This is what we want to look at. So I should have like a 2x2 matrix here, which is what I have. I have true, false, false, true, true, false, false, true. This might actually be too small now. Let's go back to what we had. Like this. And just make sure we scroll up to puzzle 5. Yep, we got our 4x4 matrix. Is this doing what I want? It's a bit hard to tell because I made it symmetrical, right? Is there a way I can make it not symmetrical? Maybe I would just say... Let's make this 12. Let's make this 11. Or actually, let's do it simpler. 6 and 5. And then just this won't be a square matrix. So like right here, I have a 4x2, which is a little strange. I think what we want is a 2x4, right? And also, so I think these are swapped. We want to look at none and none. Now I have a 2x4 And it looks like it has the correct masking. So let's come back over here. Ooh. Let's see what my Z offsets look like as well, right? Oh, one thing right here. This is N0. It probably should be N1 because what N1 represents is like how many elements in a row we've already stepped through, right? So like if we're on row 3, that means we've stepped through 3 rows, but the length of the row is going to be determined by the length of the y vector. Let's get rid of this print and this x and y. Invalid access mask. Oh, I think this is also wrong. Results match false. Let's see. Looks like quite a bit of it is correct, but a lot of the rights are incorrect. So this either means that I'm encountering some floating point math errors, or it could also mean that where I'm writing to, well, if the zeros are correct, like, that's a little strange. I might be encountering some floating point math errors, but let's see if there's any like hints over here. Yeah, see, because these are both 32 by 32. I wonder if I'm writing like the transpose or something. try just printing some stuff. Okay, I have my x values. Have my y values. Hello. That should be 0. That should be 0. So let's see, we have a row vector times a column vector, right? Row. ZJI. I'm doing the same problem I did last time. All right, so we know how to fix this, right? When I'm doing this transpose, I need to swap my x and y offsets. But this also means that I need to transpose their representations like this, right? I'm just gonna cross my fingers that this works. I don't even know if I need to adjust the other stuff. No invalid access, but basically what hinted at me that it's transposed the wrong way is that if I look at my values here, right? Like let's look at, oh my gosh, how many numbers are there? Like right here, the zeros are going down vertically, but we should see that they're going across, right? Because we have both of these are negative. Oh, I do wonder why this broke though. Maybe it's just like the wrong shape. Yeah, okay, so here I'm counting how many columns over I've gone, and then I'm doing an x offset, which means that the length of the row. So let's try that. Hey, I think that was correct. Right, let's delete this stuff. Yeah, puzzle 5, results match true. All right, so we took each PID, we took the corresponding chunk, making sure to move over the address by the correct amount according to which thread we were on. We loaded in our blocks, making sure to only read in the memory that we have permission to, which might mean that one of the blocks might get smaller, right? We took our outer product, We use TL.maximum to simulate ReLU, torch.ReLU. We determined our Z offsets in a transposed fashion, which means that we consider them as if they were arranged in like column major order, which requires us to also adjust by row length rather than column length. And we do our masks just like we would have before, and then we stored it just like we would have before. Cool. I'm gonna add this to my Git. So let's git add dot. Puzzle 5. Nice. All right, let's try puzzle 6. Oh, before we try puzzle 6, let's try running this on the actual hardware. Although, should be fine, right? Because that's the whole point of the interpreter. Yep. All right, cool. So now we have puzzle 6. We're looking at fused outer multiplication backwards. So maybe this is we just did forward pass, now we need to look at the gradients, right? So the backwards of a function that multiplies a matrix with a row vector and take a ReLU. Uses 2 program blocks. Block size B0 is always less than, just the same thing as usual. Chain rule backward DZ is of shape N1 by N0. So we have f of x equals just what we just did, and now we want to look at dxij equals f prime of xy times dzij. So we're finally getting into some derivatives, right? And I think one of the things we'll notice here is that our derivative is going to end up basically looking like a mask, right? Because when we perform ReLU, right? Let's pull up Desmos. ReLU is essentially going to look like, do they have ReLU? Maybe, just use max, right? Derivative is going to look like 0 for all the zeros, but then the derivative for any of the other values that we have is going to end up looking like just 1. It's going to be like a heaviside step function, right? So I think if I'm understanding this correctly, we should just be constructing this mask. It might not be though. Let's look at the program first and see if we can understand it a bit better, right? I have x and y. I'm taking the outer product just like before. Am I? It looks a little bit different, right? This doesn't look like a row vector anymore. But this still looks like a column vector. Maybe the result is pretty similar. Kind of want to try that. Like what happens here? But anyway, we have z dot backward. This is using PyTorch's AutoGrad on DZ, which I'm assuming is just a number, right? Or it's an array. An array of outputs. What is DC here? N1 by N0. And dx equals x dot grad. Turn dx. All right. Let's try this out, right? So if I remember, what I should be able to do is just take my code from over here, right? And bring it over here. But then the big thing is going to be instead of our outer product, we want the derivative of our outer product, which is just going to be whether the values are greater than 1 or not, greater than 0 or not. I'm not sure if this means that we can do it without actually doing the product, or if we should just do the product and then like apply a comparison function, right? Like we could do a tl.where or something like that. So that's what I'm gonna do, and we could try optimizing it later, right? But so our what should I call this? Right, we have f prime of x and y ij times dz ij. This should just be, I don't know if there's a name, let's just call it d-ReLU. Outer product equals tl.where, and just accepts a condition, x and a y. So let's say outer product greater than 0. If it is greater than 0, we want 1. Otherwise, we want 0. I'm not sure this works though, right? We need this to be an array. I don't know. Let's try it though. Let's print d-ReLU outer product like this, right? And just comment this out. I'll suspect it doesn't work though. Hey, it did work. Maybe it's just inserting, it's just, well, nice. Alright. So now we just need to multiply this by dz, right? We say dz pointer, and we need to multiply them element-wise. I'm not sure if multiplying it directly will work, but give it a shot, right? So dx pointer and dz pointer. So first thing I'm gonna do is I'm gonna say we need to load in our dz. And we'll do this by taking our z pointer and adding our dz offsets. And we'll use our dz mask that we'll make in a second. Is there anything I'm forgetting here? I think no, right? And then what we'll try putting into dx is just, we'll say tl.store our dx pointer plus our dz offsets, because I think they're the same shape if I remember correctly, right? ij, yep. And we'll also say the same thing with our, so let's just call it mask and offsets, right? Simplify things a little bit. Yeah, sounds good. So how do we actually, oh, this should be a dz, not z, like that. So how do we actually construct our offsets and our mask? What we need to do is we need to construct we need to compose our x offsets and our y offsets, right? And I think we could just do this like we did before, right? So that we could say offsets, except this time I and j is not transposed. So instead of doing the whole y n0 x, we're going to do x n1 y, right? So offsets is going to be x offsets, and we want to make this a column vector. So we'll keep all the rows and add a column. And we want to multiply this by n1. And then we're going to take our y offsets, we're going to make it a row vector. So we're going to add an axis, keep all our columns. Yank, put. And so for our mask, what we're going to want is same thing as before as well, right? We want x offsets less than n0, and we want y offsets less than n1. We want to make sure that we're doing this correctly in terms of like our dimensions, right? We want, so I think I'm doing something wrong here actually, right? Like, addition is commutative, and so is and, right? The really important thing is, what is this multiplication factor doing? Right, what I wanted to do is multiply, not only that, but what is this y offset doing? I think this should be like this, because we wanted to mirror our product operation. So let's try that. Then one more thing is, when we store this, this should be maybe if this is f, we should call this df by dx. And then we could rip offset. What's up? What's up, Ali? I should probably move this over here, right? Like, go like that. Go like this. And it's not what I meant to do, but whatever. Put that here. Like that. Now I can see chat. If Ali's still in here, you can say hey. But so, really what I should probably be calling this is like, df by dx or something like that. It's probably a little better. And then we'll just put df dx times dz in here. And one thing I want to see is like print dz, print df dx, print df dx times dz. And one of the reasons I brought up in the beginning is like, so if this breaks, which I kind of suspect it does, since df dx looks like a mask, what we can do is we can use tl.where, right? And not only can we use tl.where, but something I didn't even think of so far is that we could probably use it in place, right? Like, we don't have to keep making new tensors each time, we can use the same memory, and then we'll have a faster program because there's less I/O operations, right? But one thing at a time. First, we just try this. How do I just see, like, here we go. I have df dx. This is sort of this looking thing. I should be looking at their shape, right? Let's try this again. This should be a Z. Yo, Ali, is that a Migos joke? um, 32 by 32, 32 by 32. Oh, this should be like that. Let's try this one more time. Thirty-two, 32, 32, 32, 32, 32, and this looks like what I want, right? So I think this operation is happening correctly. The question is if I'm writing, the question is if I'm writing and masking correctly, which I suspect not. So I need to look at this, really, is what I think. I need to understand this operation a bit better. I think is what's going wrong. Let's try that. Let's try, like, I don't know, print mol relu. Let's just do mol relu block backspec of torch dot tensor. Let's say my x equals torch dot tensor torch dot tensor of torch dot rand of 4, 5, and my y equals torch.rand of 4, and dz equals torch.rand like x, should be my x, sorry. And then let's do mol relu backspec of my x, my y, so on. Like that. And then one more thing is we should print z, print
definitely find out, man. I mean, yeah, if we could get it to her, that's a perfect look.
let's print x.grad, like that. Oh, I thought I deleted this. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. So this is z. I guess I should be printing x and y, right? I want this to be smaller. Let's do 2, 3, and 2. And let's print x and print y. Try again. So much text. Yeah. All right. I've got my x and my y. X times, so what is this doing? This is keeping the rows and adding a column. So this is turning into a column vector, whereas this is a row vector. That makes sense. We have 2 rows and then a column. We're multiplying them together and we get this. And then we want to see x.grad is I'm kind of just, I think these are just multiplied together, right? Like what if I made these rand n instead of rand? So we get some zeros, hopefully. Might not though, because it's such a small sample size, but we got some zeros. Got a lot of zeros. But so, yeah, I'm getting zeros multiplied in and then 0.05 of 0.1519. I'm a little confused where some of these numbers are coming from. Like, 0.05. Let's try this. 0.05 times this is negative 0.008, which I don't see anywhere. Oh, I'm not doing this properly. Where am I? Oh, I should be printing DZ. That's what I'm missing. So over here I have 0.5675, but there's a 0. Here I have 0.1791. I have minus 0.0587. So this times this should be this, which sounds about right, but let's try it. 0. Fuck. Okay. Times this is 0.0194. Did I see that anywhere? No. Does that mean I'm doing it wrong? Maybe. It's half of 2.5, 1.75. I don't see that anywhere either. So I know this mask is working the way I expect it to, right? We see all these zeros in the same place, but I think my derivative rules are going bad, right? But I mean, honestly, let's just think about this, right? We have z equals x times y. Z equals xy. Then we know when we do z backward, we're going to be looking for dx. What does dx equal, right? We want dx by dz. No, we want dz by dx, sorry. Yeah. So dz by dx is going to equal this by dx, right? And we can use product rule here. Maybe. We shouldn't have to, though, because y is sort of a constant in this sense, right? Ah, is that what I'm doing wrong? Y is the constant. Y is what we should be multiplying, right? Let's see. I get dz equals y dx. Otherwise, if I was doing product rule, I'd do, I don't know, x dy plus y dx or something like that. And it might be that, but kind of sounds like it should just be this one, right? I don't know. X dy plus y dx. Well, let's check it out, right? So I'm going to put labels on these. I'm going to say like x, y, Z. This should be DZ. Z. Okay. So we have X tensor, Y tensor, DZ, Z, and our output should have been X dot grad, but so here I have 0.572. If it was Y dx, we should see yeah, it doesn't make sense. Let's look over here again. Did I make the stupid mistake again with the IJJI? I need to pay better attention to the indices when I'm writing these programs. But let's check. Let's come over to puzzle 6. No, it says IJ. But that might be what's wrong, right? I might need to just do this from scratch. So I need to use chain rule for this ReLU. That's fine. Z tensor is this. Y tensor is this. So I don't know. Let me see. What is this? 2. Oh man, I might need to pause this. Is that possible? I want to pause this and come back. Take a 5-minute break. Actually, let's just look at it like this. That's fine, but I want to know how. This is a fine way to do it. I don't know. Let's just try that then. Maybe we'll say maybe I'll just pause the input and then just put up a screen that says like back in 5 or something. Let's do that. So All right, and we're back. I think. Uh, let's make sure. If I remember this correctly, this should just be chain rule, and honestly, like, because this is element-wise multiplication, right? So it shouldn't even necessarily be product rule. It should just be like linearity of the derivative, right? But I'm still having trouble actually recovering the values, which means I'm doing something wrong somewhere. Whoa. Yeah. So let's check this out. We got our Z tensor. We got our DZ tensor. More like obvious way. Let's just do like, I don't know. No, I think what I had was fine. Let's do it like this again. Maybe I'm just multiplying these together, right? Something doesn't make sense here, right? dx ij equals f prime of x xy ij times dz ij. So we should be multiplying this number times just 1 or 0. So I don't understand why a different number is coming out here. Oh, derivative of this with respect to x. It's not just 1. It's gonna be it's gonna be what I said before. It's gonna be y. But so then 0.433 times, what is it gonna be, like a sum of these two? Was it that the number right there, right? No. 10120. Minus 0.0052. Hey, right there. Minus 0.0052. And then same thing right here, we have so what did I do there? I multiplied dz by y, didn't I? So that's what I'm doing wrong. I need to be multiplying by y. Got my derivatives messed up. Because y is the inner derivative if we're doing the chain rule, right? That's f prime of x right here. So let's come back to our implementation. Why did I scroll so far? Come on. Yeah, here we go. So over here, when I'm loading this x block and this y block, I need to instead of it being 1 or 0, well, 1 or 0 is fine, but I need this to be like times dy, and that might not even work properly, right? I need to like let's print some shapes, right? Let's print df dx dot shape, dz dot shape, and y block dot shape. Let's see what that comes out with. And let's get rid of some of these because like it's just cluttering stuff at this point. Let's put that over here, and let's also delete these. So we got some shapes that we printed. So we got 32 by 32, 32 by 32, and then a single 32. So if I'm thinking about this correctly, we should just be able to say times y right here, right? And what might happen is that we accumulate some error, right? But see, like this right here, honestly, could be like this, right? And then we just have our, this is our dx. So we could also just try that. Like this. Sounds correct. Let's try that. But I still think there's going to be an issue with like masking and stuff. So let's get rid of this stuff. I don't like it. So I'm looking at each thread, grabbing my X block and my Y block. Calculating my outer product. Getting my offsets for my block that I'm filling in DZ. Getting my mask. Ooh, this is kind of messed up. What is that? No invalid access detected, so I think we just fixed the mask, which makes sense because the dimensions were wrong. But now we have the wrong numbers, so let's look at the numbers, right? Let's see, yours versus the spec. Are the numbers like super off? Yeah, they are. Not even close. So one thing I'm thinking is like, but before I just start jumping in, because like I could try to like increase accuracy and stuff, but I think this is a logic error and not a floating point math error. So I'm gonna look at the logic a little bit. What I suspect is going wrong is that the multiplicate. Ooh, what's that? What I suspect is going wrong here is my multiplication by this y block, right? So I suspect what's going wrong is here, right? Let's examine this. Let's say print, print, print. And let's isolate each operand like that. Oh, gotta make sure I reactivate virtual environment. Yeah, try it again. Cool. So right here we have 0.4306. Right? And then 0.1406. Should be 0.06, which we have right here. How about maybe this just needs to get transposed, right? Is that a thing? Is there like a TL dot transpose, or I don't know, let's see. Yeah. Let's just try that, right? Because we know that this was a square shape, so it might just be the fact that it coincidentally worked out, right? And that's why stuff is messing up. Oh, but it doesn't matter because it's one dimensional. Hmm. Uh, Maybe like that. Hmm. Ooh. This looks right. 0.02. Hmm. we want yj times Hmm. 0, 2, 0, 2, 0, 0, 0. It's getting a little late, so I think after this one, gonna wrap it up. Let's uncomment these again and start messing with them again. Maybe. Let's try constructing dx from its constituent parts in the autograd graph, right? Let's try doing like I don't know, something like that. Let's try that. See what happens. So we have I have a 2 by 3, and then y is just a 2. So when I multiply them together, I need to add something after. I need to say none, like this. Yep. And then let's see if the attempt is correct, right? It's partially correct. The other thing we want to make sure is that we say, we do the torch dot condition would be z greater than 0, right? 0. I mean, that looks the same to me. 7578 00 1135 00. So I got my z greater than 0, right? That's what this output block is. Why do I keep going down so far? Right here, I got my outer product greater than 0. Then I got my dz times my. Ooh. Maybe there's some weirdness going on with the like dimensions and stuff. So let's try this. Right. Times dz block and 0. See how that goes. So it might be a problem with the with how I'm writing it then, right? Like how these are getting written into my tensors in terms of like my offsets and my mask. So maybe let's try. I feel pretty confident in my mask. I feel like it should be exactly the same as the other one, right? So this one might be the funny one, right? Maybe this is supposed to be like this. This is supposed to be like this. This is supposed to be like this. But I think no, for a couple of reasons, right? One reason I don't think it's this is that there's no reason for the transpose to come up unless I'm forgetting like a vector calculus rule. These are all FP32, right? Isn't that what I was saying before? Stop. There should be a shape in here somewhere. 32, yeah. I'm a little stumped. It'd be nice to have the debugging tools from over here. I should just try it on a smaller example as well, but see if we get this running again. Yeah, isn't it usually equals equals? Why is it written like that? But I suspect this could run into the same problem, but we could try. Hmm. So what I remember from when I was setting this up is that torch needs to be version 2.5.0 and then numpy needs to be less than 2.0, but kind of just hoping this will resolve itself and I don't have to really deal with either of them. Fingers crossed. I think it's done running, right? Yeah. Hey, that ran this time. How about this? Hey, everything's running now. So I guess all I had to do was replace that dash with the equals equals. That's kind of annoying. I don't really understand why it worked the other day, not today, but not gonna question it too much. We're just gonna put this right here. Nice. So we have these now. So let's fill in number 5, right? Because we solved number 5. That was this right here. Or was it? Bum, bum, bum. Let's make sure these are all actually passing still. Because baby stuff broke. try this again. I don't know what's up with that. I think I got stuff running, but like, is it my internet? Is my internet kind of bad? Oof. That's a oof. Yo, I haven't even been pointing at my face the whole time. Gotta make sure I'm in frame. There we go. That's better. Times this should be. I want to see my visuals. I'm so close. Let me see visuals. What the hell keeps going on? No. We're almost there. Oh, this looks good. This looks much better. Yeah. Alright. Stuff's actually running now. Ah, but see this, all these falses and stuff. Alright, so one more thing, we're gonna try and do the fix I talked about before. We're gonna say pip install force reinstall torch, and we're gonna say same thing for numpy. See if that works. So what I think was happening there was what I was talking about earlier with the NumPy version, causing errors in floating point comparisons. In the meantime, see if anything sticks out at me here. Column vector, row vector times column vector. I mean, this looks pretty like 1-to-1 with the other one. I don't want to peek at the answers yet. Damn, taking forever to install. Okay. Is there a TL.range? DZ pointer, Y block. Mm-hmm. Let's see how this goes. Just come down. Let's skip some stuff. Let's see if we can just come straight to here and run it. Damn it. Let's take a peek. Sometimes hitting your head against the wall isn't the best thing for learning. So far they look the same. The offsets are different. Let's see if we can simplify this with these again. Might be worth doing. Okay. So, first of all, let's see if we can improve 5. So I'm gonna get rid of a bunch of this work. Let's get rid of, let's say git reset -- hard head. let's don't save puzzles. See if we can simplify 5, right? I'm gonna try reusing these masks, so I'm gonna say X mask equals this, and Y mask equals this. I'm gonna say X mask, Y mask, and then for these, we're just gonna say X mask and Y mask, like that. See if it still runs. Yeah, it still worked. So let's say git add dot git commit -m. Let's say it let's say amend actually. And let's X out of this, and let's git push, and let's force it. Yeah. Alright, so now for the next one again, let's do this a little bit differently. I feel more confident that I wouldn't mess up the mask with this, so let's start there. Then also, let's write dx, let's write dx pointer here. Dx pointer, like this, right? And let's say dx equals tl.where outer product greater than 0. We're going to say y block none, just like we had before, times dz block just like that. And then otherwise we're going to put a 0. And for dz block, so let's just call this offsets and mask again. And then one more thing, we're going to say dz block equals tl.load dz pointer plus offsets, and we're going to say mask equals mask. Let's try that. Hey, stuff looks a little closer maybe. Like, this number looks right. This number looks right. I wonder if it's just transposed. Right? Like, maybe this offsets and this offset's supposed to be different. Right? So let's say the DZ offsets are like this, right? But then the regular offsets, the DX offsets, should be the opposite. I think that is what's going wrong, right? So over here, right, we have well, let's just try running some stuff. I don't know. Let's try running puzzle 1, see how that goes. Yeah, results match false, whatever. But anyway, point is, so for our outer product, right, for the definition, it was transposed, right? Right here. So we should keep in mind that dz is going to be stored in a transposed fashion too, but dx isn't necessarily, right? So right here, I should be saying like this, maybe. All these axes get confusing. Not quite. But man, we're close. So let's go back to N6, right? I want to look at this visual one more time. No. No. This. Chain rule backwards. DZ is of shape N1 by N0. Z is also of that shape. But X, dx is going to be of shape Yeah, so X is 90 by 100. Z is 90, 100. DZ is 90, 100. DX is 90, 100. I'm gonna peek again. I'm not understanding. Okay, so we got off Z. Yeah, so it looks like what I had here, right? These are also the same. Mask Z. Let's see if that's the same. Yep. Mask Z is the same. X equals TL dot load. Yep. These are the same. And then Z equals this, and then they do the where. But then they do Z pointer plus off C. This is for a different puzzle. Okay, this is what I was looking for, right? So they use where, I use maximum. The same difference, I think, honestly. For this one, I'm not understanding 100%. In puzzle 5, we use X and Y to name axes I and J. Now we directly use IJ for naming since X is no longer a vector. Yep, this makes sense. This is what I have. This one right here, offset JI, is going to be a little strange. So we have offset J, comma none. So this should be our DZ offsets, right? J, comma none, times N0, plus off I, none, comma. Yep. These are the same. Mask JI also looks similar, but let's see. X mask none, so that should be mask I none, and then Y mask comma none. Yep, looks right to me. Then we see X equals TL dot load off JI, whereas Y equals soft J. I see. I see. X is a different shape now. I feel like that wasn't made very clear though. Oh, I needed to read the, oh my gosh, this makes so much more sense. Look at the picture. It's a matrix with a row vector and takes a ray loop. No wonder this was like messing with me. The specification was like just completely incorrect. I need to read these more carefully. Damn. So let's not even look at the answer again and just consider this from X being a matrix, right? This is going to be a little bit different, right? Because it's not X and Y anymore. X is a matrix now. So I guess we could use this for y offsets, but really x offsets now should be like, yeah, this should be like I and j. So let's call this I offsets, j offsets, and then let's call x offsets equals what? X offsets equals something like this, but let's do it like this, like this. Let's just do this the way I would have if I understood it from the first place, because I think I just assumed it was like the other problem but backwards, and that's why I was having trouble, right? But so let's do j and let's do I like that, right? Then for our y mask, I'm gonna say j offsets less than 1. For our x mask, I'm gonna say what am I gonna say? And 0, like that. And we need to expand these, right? So let's make this one let's make this one a column vector, right? Like that. Which means this one has to be a row, like that. Then our x block is gonna be that. I'm gonna write this like this, so that the naming is a little more consistent, like that. And then now I get it. Oh my gosh, this makes so much more sense, right? So that this was written like this because this is a matrix now. We don't need to expand it into a row. I thought that they were just like providing it as a 1D like unsqueezed 1D, and they did it differently just like arbitrarily. This makes way more sense. Alright, so here we have our x block, we have our y block. Outer product should be x block without any unsqueezing times y block, like this. DZ offsets are transposed, I think. Like this. And then the mask is still gonna be still gonna be our X mask, I think. I don't know, we'll see. And then DZ block is gonna be, let's just put X mask here. I feel like we're gonna have to switch it. Yep, this makes sense. Let's get rid of this. And let's put DZ here. Does this make sense? I'm not even thinking about this very much, but let's see if it runs. We're closer. Let's see how this went. Yeah, I don't know what's going on over here. Alright, so let's look at this again. We got our PID 0 and 1. We've got our... Yep. This makes sense to me. I'm gonna go put this here, and then I'm gonna say, like this. Like this, right? So I have my PIDs, have my offsets. I do my Y stuff. I do my X stuff. I create my outer product. I do my DZ stuff. Now I need to do my DX stuff, right? DX equals this. Let's try DZ offsets here. No. Yours should be 0.7. So now that we have it clear that it's a matrix, I should probably be thinking about it a bit more explicitly that way, reasoning it that way. I'm also just feeling a little tired. I don't want to quit though. We're almost there. So let's do parity 0, parity 1. Sounds right. This looks right. Right, we're jumping ahead to the correct block. We don't need to revisit this. This also looks correct. This part. How's this? Maybe we have X offsets, X mask. We got TL.load, X pointer plus X offsets, X mask. So we have our X block. Sounds correct. X blocks times Y block, comma none. That's what's up here, right? Yep. 0. Its outer product looks correct. And then well, we don't really need to do this maximum because we're already looking at whether it's greater than 0 anyway. So let's just do that, right? That's one thing we could change. Simplify. But then also, right, like we never actually used array loop because we're not returning it anymore. So that's one less operation we could do. But then also, so we have DZ offsets equals this. Why are they transposed? Because do I need to make a separate mask? I don't really understand why you'd need a separate mask. Now let's check it out. This is the expression I had before. That looks right. Yeah, they all use the same mask. Yeah, my stuff looks almost like perfectly right. What is... It's probably something very simple. Oh, they're all loaded in transposed. I just need to be consistent. So like... Should probably just call it this, right? Bring this up here. like that. Isn't this commutative? I think so. It's just that, isn't it? Yeah, it was just that. It was just a dimension. Oh man. All right. Well, I'm gonna add that to my GitHub, and we gonna sign off for tonight. And we know for next time, I need to brush up on one. Well, first of all, I need to make sure I very, very clearly read the problem statement and don't assume that it's an extension of the previous problem. But more importantly, I need to get a better grip on transposed operations in PyTorch. Um, I should make like a transposed game or something. If you're watching this and you would be interested in a transposed game that helps you get your PyTorch dimensions down packed, I don't know, leave a comment or something. But yeah, I'm gonna say git add dot git status. Let's do puzzle 6. Git push. All right. Thanks for watching. I'm gonna sign out. And yeah.